who I know and worked for many years, so it's a great pleasure, and actually probably the highest pleasure to me to introduce the semantic web. I only wanted to tell you that I'm not biggest specialist of semantic web. I happen to be a practical man, but I know little, so I hope that I will still be able to explain that new thing to you. Before I really start telling about semantic, I would like to tell you what is the global plan of my lecture or presentation. First of all, I will tell you a little bit about the evolution of the web. So we'll put semantic web into the context of the growth of the web. And then we will switch to the discussion what is really wrong with today's web. So we'll actually explain why we feel that we need semantic web, that we need linked data and all other names that are given to this new kind of web, showing what are the current problems. Then I will go into some fundamental foundations of semantic web. I will have one slide about technology, no more, so forgive me that I'm a technology man, so one slide only, and one slide about philosophy, and a little bit about history of semantic web. Then we will make a short rendezvous, showing where we can really meet semantic technologies in action today on the web. So that's, I believe, something very practical. And I will end my short presentation with discussing the transformational role of semantic web, what it really means for business, what it could mean, and how it changes the shape of marketing today. So that's the plan. Okay, evolution. So first and foremost, we tend to forget that web is only 8,500 days old, which is extremely short time when you compare that to the history of civilization. And having in mind what the web is today, how important it is to the knowledge propagation, remembering that it's so young is extremely important. And over these 23 years, 8,500 days, we witnessed three major eras of development, of different changes in the web structure and in the web meaning. We started the web as Web 1.0, which was basically the web of hyperlinked documents, and that started in 1989. I will tell you a little bit more exactly how it started and when and where in the history part. And this short, simple picture shows you exactly the nature of the web as it existed in the beginning. The web when it started was the web of documents linked by so-called blind hyperlinks. Hyperlinks that say, okay, you can go from this place in the document to some other document. And that's this simplicity that brought the web to existence. There is no clear cut when Web 1.0 ended. I would say it never ended yet, okay, it's actually still in place. But it was somehow extended by the concept of Web 2.0. And to me, the most important part of Web 2.0 was read-write concept. So on Web 2.0, you could have blogs, you could have wikis and other solutions, and probably the most important emanation of that era is Wikipedia, where everybody can write the post article. And also, many people stress the notion of social media and social networks that are extremely important right now. Not need to say anything about Facebook and other solutions. And the famous label was coined Wisdom of Crowds to designate actually how the knowledge is created on the web. So this is Web 2.0 and we are in this era, certainly. Now, what starts actually now and what started formally, almost formally, 2 years ago is Web of Data, the main topic of our meeting today, which actually replaces the gigantic graph of pages or resources connected by links with more advanced links, with more advanced objects. So the pages are being replaced by concepts, things, people, and simple links are being replaced by typed links, so links that have some meaning, that what they really point to. We'll tell more about that later, but that's in the historical context, okay? So these three eras, we just start Web 3.0 right now as we speak. wrong with the current web, why we really need semantic or some evolution to enhance our experience with the web. First and foremost, the web is big. And just to imagine the size and actually the growth of web, it's always good to listen to Eric Schmidt, Google CEO, who in 2010 wrote this famous sentence. Between the birth of the world in 2003, there were 5 exabytes, exabyte is 1 million terabytes, by the way, of information created. And we now create 5 exabytes every 2 days. And that simply shows the scale from the dawn of civilization, probably 3,000 years ago or more, until 2003, 5 exabytes, and 5 exabytes since then, every 2 days. And this is not a bad thing in itself. It's beautiful, it's fantastic. The only problem is that we really don't know how to handle this, how to interact with that enormous data. Google probably has problems with that already. Okay, that's something that is extremely large to such extent that it's very hard even to explain. If you look at the Cisco data, which actually shows the transfer data, not the amount of information created, but the amount of information transferred, we see that today we have almost 1 exabyte per, well, 2 exabytes per day, and we'll go beyond 100 exabytes in 2016 of information being transferred on the web. So that's another dimension of the problem. So the size is the first, the mere size, amount of data. However, another problem, even more deep, is that according to the famous title of the book of David Weinberger, the internet philosopher, this is the guy who wrote the Cluttery Manifesto, if you remember this famous book that started, actually this book started Web 2.0 in some way. He wrote last year an interesting book, Too Big to Know, and he actually explains that the growth of internet is in some sense indebted to the knowledge having no limits, the knowledge having no boundaries. But on the same, there is also the problem with that, because if we have no boundaries, we also lack the structure of knowledge. We don't have foundation. See, in the old times, there was very easy to base knowledge on something, and what this something was: books, qualified articles, university lectures. That was quite easy to understand. It was stable. We could refer to this, right, to established books, to articles, to lectures, to wise people. No longer the case. Okay, we see this evolution on Wikipedia particularly, and we may like it or not, but we see how it changes dramatically. We really lose foundation. On the net, every fact has an equal and opposite reaction. We know that. And this is another big problem that actually this beautiful book is devoted to. And in the end, it exactly tells that semantic web is the solution, probably, because Weinberger is always questioning things. Okay? The third major problem that we identified is social web, social media. What is the problem? First and foremost, we have a problem with Facebook today because there is saying that Facebook created a new product, and these products are we, or the product is myself. Okay? Even if I don't pay, even if I don't sell myself, I am the product. So this is one problem, and because of that, Facebook has got some problem on IPO. Okay, so that's another story. But from the context of the web evolution, the problem with Facebook and other social media is that they are isolated. Okay, they are completely like in completely isolated silos. There is no connection, as you know, between the data that you have about yourself and your friends on Facebook and on some other platform, unless you actually use Facebook for login and something. So Facebook says, okay, you can export the data as long as you use Facebook login. Okay, and I am not telling here that Facebook is evil. Actually not. Facebook has a great thing for semantic web. It's Open Graph, very popular standard, and that's very good. But I say about some pattern, and the pattern is simple. Some social media exist in isolated silos that are controlled by entities that do that for some purposes. We don't really know yet if these purposes are good or not. Okay, so that's a fundamental problem.
why it is a data problem is because we can't simply we are not ourselves, we are not the data about us. We are deeply in the Facebook databases somewhere, we don't even know where, okay? Not physically where, I mean logically where, okay? We don't have this information. And the last, not least problem is the search engine barrier, okay? And some people will call that Googleization of everything, or another saying is that Google became a verb, okay? Let's Google it, everybody knows that. And again, I'm not against Google, I don't say that Google is evil also. Actually, Google is absolutely fantastic, probably thanks to Google we have today the real growth of semantic web since last 2 years. But the very nature of search without semantics in place requires huge centralized control over indexes. So it's no wonder that probably it had to evolve to such a situation that we have one huge supplier through whose goggles we see the world, okay? And that's dangerous, not only because Google is monopoly, right? I try to be away from that. It's dangerous by itself that we tend to think about the web and world through one company, goggles, okay? And that's extremely dangerous. So here's the solution, of course, semantic web, but we must be a little bit careful if it is really the solution. It tries to be, and we are sure that it will be the solution, but of course that will time show. So maybe in the next couple of years when we'll be doing MakoLab Semantic Days 25 years down the road, we will see, okay? At least next year we will see more, probably what's going on really. So, what are foundations of semantic web? What it really is, so what we call semantic web. First, let's analyze what word semantic means in semantic web. And a very simple saying is that it's about meaning of data, not about syntax. And one of the most beautiful illustrations that I found about that is this illustration by Manus Forni, a person from the company Digital Bazaar, that was quite important for semantic web in the beginning. And he explains in his lecture that we can express I love technology through writing I love technology, but we can exchange the love of a word by the symbol of a heart, and completely different syntax, the same meaning. Right? So this is exactly the simplest notion of semantics in semantic web. We are concerned with meaning of data, not with the data syntax. Okay? Another good example, and very simple actually, is when we have the concept of street address. Every company has contact information and street address. Now, if we go to the current multilingual, multicultural web, we see in the websites a lot of different words that mean address, street address. And not only words, so you can't really translate them between English street address and ulica in Polish or gatve in Lithuanian, sorry. You really need to somehow move the context, okay? Because sometimes the word, the literal translation is not exactly the concept. So at the end, we have different syntaxes, different words, and the same meaning. So again, this is what semantics is. Completely, potentially different syntaxes, the same meaning. So this causes the possibility to call the semantic web full of meaning, or web of meaningful data, or web of data, whatever we call that. Really, this labeling doesn't have any sense if we understand the basic concept. And we can also say that semantic web is about representation of things, objects and concepts and their properties, not just about documents. So we go away from document, HTML, we go into the data, the concept. Also, the very important thing that semantic web uses global naming scheme, I will explain it later, to identify things, not just to address documents. So we have some method to say, this is this object, okay, in the objective way. Then semantic web links these concepts, these things, through typed links, not just blind hyperlinks. Okay, so this is another advantage. And finally, in the most advanced scenario, semantic web allows for discovery of new facts about things, not just for browsing through pages. When I mean discovery, I mean that there can be findings, some findings that are not explicitly expressed they are implicitly only inferred from the data on semantic web. Okay, so this is the short, glimpse. Now we go to atom. What is the atom of semantic web? And here we go to the probably the most shocking thing, that the atom of knowledge in semantic web is extremely simple. This is like a simple affirmative sentence, okay? We say something has something, okay? Something does something. So we can say subject, predicate, object in the linguistic manner, or we can say subject, verb, object in this way. Or if you are a little bit more for IT, you can say thing or object has some property, and this property has some value. And this triple is the fundamental block of semantic web. No more, no less, but also no more. So it's really that simple. We don't have any mysterious data structures. We have simple sentences. Something is something. Something has something. Something does something. That's an atomic knowledge element. A good example of that is, for example, if we try to go into automotive context, we may have some Renault Clio Sport, and this car may have some VIN number. So this is subject or thing. This is property, and it has some value, some label. So this is like a literal triple. Okay, literal. I mean, literal value, the string. Okay, this VIN number. But we may have also concepts that may be in the place of objects. So for example, this same Renault Clio car, we may say that has engine, and the type of engine is 2.0 liters tri-4. I'm not sure if I say correctly according to Renault nomenclature, but there was such engine, I believe, right? Now what is the difference is that here we can actually follow this object if it is properly expressed, as you will see in the next slide. You can follow this, you can discover what really this is. And this is why I said before that semantic web allows for discovery, because you do not stop at the value. You may actually follow the value and discover what it really is. So this atom of knowledge, these triples, they can be stored in specific format, and this format is called RDF, Resource Description Framework. And the very easy thing to remember always is that RDF is for things, as HTML was for documents. Okay? So that's exactly the analogy. As we have HTML for the current web, then we have RDF for the future web, and this is its structure. The second important thing, how we identify things. That's extremely important, because identification of objects in any knowledge representation is a hard part. Okay? We know that ISBN for books, for example, are they general? Not necessarily, right? So when semantic web was born, people were thinking what actually to use for naming, and they decided to use something that is very close to our heart. It's simple web address. Actually, it's a little bit more general. We call it URI, Universal Resource Identifier, but for the purpose of our understanding, it really doesn't matter. The name is the address of something. It may be the address of a page describing this object. It may be something else. There are some complicated things like content negotiation about that. I will not go into these details. But anyway, the simple notion is that we have the standard web addresses as identifiers. Why? See, thanks to the naming, to DNS, we have fundamental thing. This address is unique. We have guarantee that there are no two pages that have this address. Okay, there's only one page that has this simple address. So that's the naming scheme, and we can have that kind of address, or we can have such type of address or URI, which actually point to the Hepp says ontology, another invention of Professor Hepp, who will tell us a little bit more later about that. So VIN number has this definition. Okay, so summing up, on semantic web we identify things with addresses. And the purpose of that are two. Uniqueness, and second, ability to follow this address and to find some information about what we really talk about, okay? Links. Basically, the difference, once again, about linking in the standard web and linking in semantic web is best illustrated by this little part of diagram from GoodRelations ontology. We will have a specific lecture today about that. company offers and where this company has stores. And these links have types. Okay, so these links are not blind, like from company to something. We know really what this object is all about by having these type links. Okay? So this is the nature of link. Links are categorized. Okay, and there are some vocabularies to say what these links really are. Now this discovery part, there is a lot of upper tools which I will recall later. Anyway, the most important thing is that you may have some simple reasoning, some simple inferencing of the semantic web. And it can be very practical. For example, we may have a scenario that when a user on some automotive website searches for a car with some specific engine features, we may discover on this website that it is possible to offer him another car that belongs to the same class of cars because of this feature. Okay? So we can make a very simple logical relation, and in principle we can do that on the website itself. You do not need search engine to make such a search. So this is probably the simplest example of reasoning on the semantic web. Now, semantic web can grow really big. So in 2007, Tim Berners-Lee, the person who I will be telling a little bit more later, coined the term GGG, Giant Global Graph, because if you actually create these atoms of knowledge and you follow these links, you create more and more information. So from the simple diagram of several objects, you may go to thousands of objects on DBpedia. This is obsolete, and you can go really to the big structures, to so-called triple stores, or to big semantic databases. They have really millions or even potentially trillions of triples. I will probably tell you a bit ahead of time, but if you go to Google Knowledge Graph, they claim to have 3.5 million facts or 3.5 million triples already in the knowledge graph, and that's only from the data that they collected. Right? They still don't take the data from the web. When we start, this will grow really big. Okay, everybody probably knows that I'm technology. MakoLab is a technology company, so I couldn't avoid having one slide about semantic technologies very, very quickly. Just some names will resonate in your minds later. As I said before, RDF is the most fundamental thing. It deals with things, and it, once again, RDF is for things like HTML was for documents. Okay, that analogy should be always remembered. Then we have a little invention, which is why it's indentation. It's RDFA, which says RDF in attributes. What it is, it's actually the specific technology, specific format that can be used to embed or to put semantic information into existing web pages. Okay? So we really don't need to build triple stores. We can put semantic information into the code of the pages. Martin will tell more about that, how we do that practically. Then we have something we call schema language, RDFS, which the simplest name or simple description could be that, like, RDF deals with things, then RDFS deals with sets of things. So we have collections, we have classes, we have domains and ranges, we have more than simple facts. Okay? We can combine and define them in schema. Then we have OWL, which reads ontology web language. And this word ontology smells in a philosophical way. There is something from that, okay? There is something, but don't be afraid, it's not philosophy, it's actually vocabulary. Okay? OWL, the ontology, is simple vocabulary with, of course, some logical relation between concepts, and that makes this non-trivial. Okay? And Martin will tell us about the ontology GoodRelations, which is a good example. So you will see that it's simple and not simple by the same token, and creating ontologies is really the art, not because it's complicated, but you need to be very concise and very specific about what you are going to express in that. And finally, as any technology of big data, semantic web has its own search protocol, like SQL for standard databases. Then for semantic web we have Sparkle. It's actually probably simpler to learn than SQL, and it can search these huge graphs with enormous speed. So that's what Sparkle is. That's enough for technology for today. Okay, and some people who know my blog, I know that I tend to philosophize also. So I couldn't avoid having some one page about philosophy of semantic web. I would tell about two philosophical concepts and one hypothesis. So first, we have this famous slogan, American Automotive Association, or AAA Battery. No, anyone can say anything about any topic. That, what it means in practice is that on semantic web there is no central authority by design. Okay, so semantic web is as web itself. There are no central authority. Anyone really can say in these formats, in this data, anything about any topic. That potentially could cause problems, but if we look into the different organization, if we look into these ontologies and vocabularies, we see that there is growing order of the different kind. This slogan also guarantees fundamental thing, that semantic web will always be social. And that's very important. Ontology actually, as Martin explained, is social contract between people who wanted to use it. Okay? So AAA, for me, is simple. Anyone can say anything about any topic, but it also guarantees that semantic web is not revolution, it's evolution of the current web. It's the extension of Web 2.0 toward the web of data, and the understanding of the web of data becomes social. That's very important to know. Second, open world assumption. Actually, this concept is known to some logicians. It's a logical concept. It simply means in semantic web context that we must assume that at any time a new piece of information can come, so we can't assume that we have all the information at the moment of information consumption. We always must expect in our application that something new appears. And also, very important thing, that if we don't know something, that doesn't necessarily imply it's falsity. Okay, so if we don't know, we can't say it's false. Okay, that's very important, so-called philosophical concept of semantic web. And something that I like the most, it's James Handler. James Handler is one of the fathers of semantic web with Tim Berners-Lee. He coined this beautiful sentence, "A little semantics goes a long way," and he put that on T-shirt on some first semantic project. The project was called Shoe. Doesn't matter, but anyway, this hypothesis tells that maybe semantic web was a little bit too complicated in the beginning, and we really need to go with little semantics. And that's true, in some sense. We see Handler's hypothesis in action in something we call linked data, which is like a subset of semantic web. And it has fundamentally 4 principles only. No schema, no ontologies. We have only, we use web addresses as names. Then we use these addresses, they must work on the web, so people can look up for these names and discover something. And if somebody goes for this address, he finds the useful information that is expressed in standards, in these semantic standards. And finally, that we include links to other URLs so that they can discover more things. And this saying and this cap is from Tim Berners-Lee lecture. Okay, so that's a little semantics in practice. Short history. One minute history. That's very personal. I know that many people will not agree with me, so remember, this is Mirek personal. I tend to think that Tim Berners-Lee should have the Nobel Prize if something like that existed.